Hello guys, welcome back to this learning. This is the second part of atomic structure chapter. In this session, we will derive the expressions of radius, velocity and energy of an electron revolving in a Bohr orbit, and we will learn their physical interpretations and some numericals. Okay, if you yet haven't seen the first part of atomic structure, you can see it. The link is in the description box or on the I button. Without wasting any time, let's get started. So now we are going to derive the expressions of radius, velocity and energy of an electron revolving in a Bohr orbit. So this portion is very important. अच्छे से दिमाग लगा के देखो. So we are considering the nucleus here, where the charge of the nucleus is Z into E. If the nucleus contains Z number of proton and the protonic charge is of course identical with the magnitude of the electronic charge, and here is the electron which contains the charge E. So when the electron revolves around the nucleus, two types of force acting on this electron. One is centrifugal force, which is acting outwards from the nucleus to the electron, and one is centripetal force, which attracts the electron towards the nucleus. So these two forces act simultaneously on the electron, and the direction of the velocity of electron is tangentially to the circular orbit. Okay, so we can write at the stable condition, of the atom, the centripetal force must be equal to the centrifugal force. This is very obvious. Just take an example. मान लो तुम उंगली से एक धागा बांधकर इससे एक पत्थर को घुमाते हो. सो उस पत्थर के ऊपर दो टाइप्स ऑफ फोर्स काम करते हैं. एक होते हैं बाहर की तरफ सेंट्रीफ्यूगल फोर्स, और दूसरा होते हैं उंगली की तरफ सेंट्रीपेटल फोर्स. So the same thing occurs here. One is centrifugal force and other is centripetal force. Under the stable condition of the atom, these two forces become equal. So the source of this centripetal force is of course the electrostatic attraction force between the nucleus and the electron. And as we know, the Coulombic attraction force F equal to Q1 Q2 by R square. Considering only the magnitude, of course, F equal to Q1 Q2 by R square. So here the centripetal force is Z into E by R square. The distance between the electron and the nucleus is R, and here is the charge Z into E, and here is the charge E. So the centripetal force is Z E square by R. और फिजिक्स का रिवोल्यूशनरी मोशन चैप्टर से तुम जानते हो. दिस एक्सप्रेशन ऑफ द सेंट्रीफ्यूगल फोर्स is of course mv square by R. So these two become equal. From here v square equal to Z E square by m into R. So this is our equation number 1. Okay, and from Bohr's theory we know, I can write here, from Bohr's theory as we know mvr this is equal to nh by 2 pi, or you can isolate v from here, v equal to nh by 2 pi mr. Now squaring both sides of this equation we get v square equal to n square h square by 4 pi square m square into r square. So this is our equation number 2. Okay. Now we can equalize the right hand side of the equation number 1 and 2. We get, I can rub this one, so equation number 1 and 2 imply z is square by mr, this will be equal to n square h square by 4 pi square m square into r square, right? So now we have from here r equal to n square h square by 4 pi square m into z into e square. Okay, so this is our expression. So this is the expression of the radius of a Bohr orbit. This r is designated by Rn, of course. This is the radius of nth orbit, so this is represented by Rn. So this is our equation number 3. It is the expression of radius of Bohr's orbit. Now from here we can calculate the radius of the first orbit of hydrogen atom. We can write, for the first orbit of hydrogen atom, for the first orbit of hydrogen atom, we can write z equal to 1 and of course the n equal to 1. This is the atomic number for hydrogen. This atomic number is 1, and for the first orbit of hydrogen atom n equal to 1. So we have from here r1, this is the radius of the first orbit of hydrogen atom. This is 1 square into h square by 4 pi square m into 1 into e square. Now take a look. Now take a close look here. All the symbols have a definite value. H is Planck's constant, pi is 22/7, m is the mass of the electron, and e is the charge of the electron. So substituting all the numerical values of all the symbols, we get the value of the radius of the first orbit of hydrogen atom. This is 0.529 angstrom. Okay, this is the radius of the first orbit of hydrogen atom. or this is equal to 0.529 into 10 to the power minus 10 meter. Okay. Now we can use this value for calculating the radius of different orbits of hydrogen and other hydrogen-like systems. For other hydrogen-like systems, we can write this Rn for other hydrogen-like systems Now this hydrogen-like systems means the system which contains only one electron. जो सिस्टम के पास एक इलेक्ट्रॉन होते हैं उसको हाइड्रोजन लाइक सिस्टम कहते हैं. Like say He plus, it contains one electron. Li2 plus, it contains one electron. Be3 plus, it contains one electron, etc. These are known as hydrogen-like systems, and we can write for these systems Rn equal to R1 into n square by z. n square by z. ठीक है ना? This is Rn, and R1 includes all the terms here except this n square and z, because for hydrogen atom n equal to 1 and z equal to 1, so except n square and z, n square by z, all the terms involved here is R1, so Rn equal to R1 into n square by z. Take an example here. Say radius of second orbit of Li2 plus ion is simply R2. This is equal to R2 means the second orbit, so it is 2 equal to R1 into n square by z. Now for the second orbit of Li2 plus, n equal to 2, this is the second orbit, and z for lithium, z equal to 3. So this is R1 into 4 by 3. This R1 equal to 0.529 angstrom into 4 by 3. This one, and this value is around 0.7 angstrom. So this is the radius of the second orbit of Li2 plus, right? Okay, let's move. Now we have to get the expression of velocity from Bohr's theory, from Bohr's condition of angular momentum. mvr equal to nh by 2 pi. So v equal to nh by 2 pi mr. Now we just substitute the value of r from expression 3. We get the velocity of the moving electron. This is nh by 2 pi m, and the value of r is, as we get from equation number 3, what we get in the equation number 3, r equal to n square h square by 4 pi square m into z into e square. Okay. So we have v equal to 2 pi z square by nh. So this is actually Vn, the velocity of the nth orbit of a hydrogen-like system. So this is your equation number 4. We get the velocity of the electron which is revolving in the nth orbit of a hydrogen-like system. Now from here we can calculate the number of revolutions made by the electron per second. So we can write number of revolutions made by the electron per second this will be equal to definitely velocity divided by the circumference or perimeter of the circular path. So divided by perimeter or circumference. Okay, so our expression of velocity is 2 pi z square by nh, and the perimeter is 1 by 2 pi r. Okay, so perimeter is 2 pi r, and this is the expression of velocity. Now move forward. So we can continue this one from here. This one is 2 pi z square by nh into 2 pi r, 1 by 2 pi r, 1 by 2 pi, and again the value of r is given by equation number 3, that is n square h square by 4 pi square m into z into e square, which gives us this 2 pi and 2 pi cancel out. So this one is 4 pi square mz square e to the power 4 by n cube into h cube. So this is the expression of number of revolutions made by the electron per second. Okay, let's move forward to the energy expression. The energy of an electron revolving in a Bohr orbit, in a Bohr orbit, this is E, and this E will be the summation of the kinetic energy and potential energy. This electron has two types of energy. One is kinetic energy and other is potential energy. So this is kinetic energy. This is Ek plus potential energy. Potential energy, this one is EP. Okay. Now, as we know, the expression of kinetic energy this is nothing but half into mv square, and now we have to find the potential energy. This is very interesting. Take a close look here. Say this is our nucleus and this is the first orbit where the electron is present here. So the distance between the nucleus and the electron in this orbit is r, and say this electron was present at the infinite distance, say at here, and at this position the distance of the electron from the nucleus is r equal to infinity, and the energy of the electron E is equal to 0. So the energy of the electron is 0 and distance of the electron from the nucleus is infinity. Now this electron moves towards the nucleus, and what will happen when the electron moves towards the nucleus? The work done by the electron is stored as the potential energy of the electron. When the electron was present there, its potential energy is 0, and when it moves towards the nucleus, the work done made by the electron is stored up as the potential energy of the electron. So the potential energy, so the source of the potential energy of the electron is the electrostatic attraction force between the nucleus and the electron. So we can write the potential energy is integration r equal to infinity to r equal to r. Lower limit of r is infinity and upper limit of r is the distance from the nucleus at the first orbit. So this is r, and this is z square by r square. This is the value of the potential energy, this is the value of the Coulombic attraction force, and into the variable is dr. This is the differential change of the distance r. So the differential change of the distance of the electron and the nucleus is denoted by dr. So the value of this integration gives us the potential energy. Okay, this is a very important idea. Okay, I can rub this one. Now this expression gives us, this is half mv square plus z square is the constant term with respect to the distance. So this is z square into dr by r square, give us minus 1 by r. So r is the upper limit and infinity is the lower limit. This one is half into m into v square. Now we can substitute the value of v square from our equation number 1, that is z square by mr. क्या तुम याद कर सकते हो? This v square comes from our equation number 1, which is z square by mr, which we got by equalizing the centripetal force and the centrifugal force. Okay, plus this is plus z square, this is minus z square by r. Okay, and cancelling the m value, we will get half into z square by r, and this is minus z square by r. This we have minus half into z square by r. Okay, and now we have to again substitute the value of radius in this expression to get the final expression of total energy. Okay. So now energy E is equal to minus half into Z square by R. Now again we have to substitute the expression of R, that is n square h square into 4 pi square mz square, and from this we get the energy expression. This is equal to minus 2 pi square mz square e to the power 4 by n square into h square. Okay, this is denoted by En, and this is the energy expression for the electron revolving in the nth orbit of an hydrogen-like system. So this is the energy expression. This one is very important, and there is one important thing that we have to extract out from this derivation, that take a close look here. This portion is actually the kinetic energy of the electron, isn't it? And this portion, this one, is actually the potential energy of the electron. This one is equal to EP, sorry. This one is equal to potential energy of the electron, and of course this one is the total energy of the electron, and this one is equal to E. So from this portion we can make a very important conclusion. Look, the magnitude of the total energy and the kinetic energy is same. So the kinetic energy is equal to minus of total energy, and the potential energy or the total energy is half of the potential energy. So this portion is very important for various competitive exams, NEET, JEE Mains, JEE Advanced, etc. इससे एक ही क्वेश्चन बार बार पूछा जाता है कि व्हाट इज द रिलेशन बिटवीन द टोटल एनर्जी, काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी. सो वी कैन राइट फ्रॉम हियर total energy of the electron, total energy E, this one is equal to minus of kinetic energy, this is Ek, and of course total energy E is equal to half of potential energy, this is EP, isn't it? This is total energy and this is potential energy, and of course kinetic energy, this is Ek, this one equal to minus half of PE, that is EP, potential energy. So these are very important relations for a competitive exam. You have to keep in mind these things very carefully. Okay. Now move forward. From this expression we can calculate the energy of the first orbit of hydrogen atom. Now the energy of the first orbit of hydrogen atom we can write E1, this one equal to, and of course for this calculation we have to assume that Z equal to 1 and definitely N equal to 1 for hydrogen atom, the first orbit of hydrogen atom. Now E1 equal to minus 2 pi square m into 1 square into e to the power 4 by 1 square into h square. And substituting all these constant values, we get this one equal to minus 2.176 into 10 to the power minus 18 joule per atom. This one, okay, and this energy is very often it is expressed in electron volt unit. So we have to convert it in electron volt unit. This is 2.176 into 10 to the power minus 18 divided by 1.602 into 10 to the power minus 19. This is the conversion factor, electron volt per atom. Of course, as we know, 1 electron volt equal to the electronic charge joule. 1 electron volt equal to 1.602 into 10 to the power minus 19 joule. So dividing this one, we find the value is minus 13.6 electron volt per atom. This is a very important relation. This is the energy of the first orbit of hydrogen atom. This is minus 13.6 electron volt per atom, and from this value we can calculate the energy of different orbits of hydrogen-like systems. And of course we can make another relation from these two expressions. Take a close look. This one is En equal to E1 into only except Z square and N square, all the values are incorporated, all the other terms are incorporated in the expression of E1. So E1 involves all the other terms except Z square by N square. So we can write En equal to E1 into Z square by N square. So this one is a very important relation for calculating energy of different orbits of different hydrogen-like systems. Okay, take an example. We can illustrate this one. Let's say the energy of the third orbit of He plus, which is a hydrogen-like system. This one equal to, we can write this one as E3. This is the energy of the third orbit, so it is E3. E3 equal to E1 into Z square by N square. The value of Z is 2 for helium, so it is 2 square, and the value of N is 3, so it is 3 square. Okay. Now this one is nothing but minus 13.6 electron volt per atom, just made, into this one is 4 by 9 electron volt per atom unit. Okay, this one, and from this one we will get so 1.51 into 4 electron volt per atom. So this one is nothing but minus 6.04 electron volt per atom. This is the energy of the third orbit of He plus ion. Okay. So lastly, in this session we will discuss the significance of the negative term in the energy expression. We can write here the significance of the negative sign in the energy expression. As we know, the energy expression is En equal to minus 2 pi square mz square e to the power 4 by n square h square. Now we are going to discuss the significance of this negative term, this one. What is the significance of this negative term? So take a close look here. So this is the nucleus, and as we go outwards from the nucleus, the energy of the orbits increases. But at the infinite distance, this is your infinite distance. When the electron is present at the infinite distance, its energy is 0. So the maximum value of energy is 0 at the infinite distance. So when the electron comes closer to the nucleus, what will happen? Its energy is decreased, and the maximum value of the energy is 0, and its value of energy is decreased from 0. So when the electron comes in the orbit, its energy is negative. Okay, it's right. So if we want to remove the electron from this orbit, if we want to remove the electron from here, you have to supply that amount of positive energy which the electron possesses at this energy level. Say this is the energy of the electron. Energy is E1. Here the energy is E2. Here the energy of the electron is E3, here is E4, and here is E5. So at this level or any of this level, the electron contains some energy, and when you have to remove the electron from here, you have to provide that amount of positive energy which the electron possesses at this energy level. So actually the energies are actually negative energy. The electron possesses negative energy at the energy levels in the Bohr orbit. And say I can give you some quantitative idea. Say this E1, this energy is minus 13.6 electron volt. This one is minus 13.6, and this energy level, it is 13.6 divided by 4. So this energy is around 3.2 minus 3.2 electron volt, and at this level the energy of the third orbit is minus 13.6 divided by 9, that is around minus 1.5 electron volt, and here is 13.6 divided by 16, this one is around minus 0.8 electron volt. So the energy of the first orbit is minus 13.6 electron volt. So when we have to remove this electron, we have to provide positive 13.6 electron volt of energy, and when you want to remove this electron from here, you have to provide positive 3.2 electron volt. So you have to provide more energy to remove this electron from here. As the electrons come closer to the nucleus, its negative energy is increased. So we have to provide more more positive energy to remove the electron which is closer to the nucleus. So this is the significance of this negative term in the energy expressions. All the energies in the electronic orbits are negative. So that's it from this video. मिलते हैं अगले वीडियो में. बस सीखते रहो और मज़ा करते रहो. बाय बाय फ्रॉम नाउ.